Hello students, in this video we will learn about the conductivity and the relation between current density, conductivity and the intensity of electric field or electric field strength. Okay, so in the previous video we had studied about the resistivity. So what is the definition of resistivity? Resistivity of any conductor is numerically equal to the resistance of that conductor per unit cube. Okay, so in what is the relation between resistivity and the conductivity? Actually, the definition of conductivity is that the conductivity of any conductor is reciprocal to the resistivity of that conductor. Okay, here the conductivity is denoted by the letter sigma here, and by the definition the conductivity of any conductor is reciprocal to the resistivity of that conductor. Okay, so we know that the formula of resistivity is Ra upon L. Okay, this is the equation first and this is equation second. Okay, now we know that the resistance of any conductor, the formula of resistance of any conductor is R equal m n e square tau into L upon A. This is the value of resistance. Okay, now on putting the value of resistance in this equation, second equation, the resistivity is m n e square tau L upon A, and this is the value of R, and multiplied by A upon L. So here A upon L, A cancelled by A, L cancelled by L, then the resistivity of that conductor is m n e square tau. This is the expression for the resistivity, okay, which we had derived in the previous video. Now we have to find the value of conductivity. On putting the value of rho in from this equation, in this equation, so we will get sigma equal 1 upon the value of rho here m upon n e square tau. Okay, or sigma equal n e square tau upon m. This is the expression for the conductivity. Okay, now the factors affecting the conductivity. Which factors affecting the conductivity? Here E, small e is the charge of one electron, so it is equal to minus 1.6 into 10 to the power minus 19 coulomb. The value of electric charge, the value of charge on one electron is fixed or constant. M is the mass of the electron. This mass is also constant. That's why sigma will be directly proportional to n from this equation, and sigma proportional to tau, directly proportional to tau. So the sigma or the conductivity of any conductor depends upon two factors, n and tau. So we will discuss about this. So what is n? N is the number of free electrons per unit volume of that conductor. So you know that for different materials, the electron per unit volume are different. Okay, means this number of electrons per unit volume determines the nature of the conductor. So here conductivity depends on the nature of that conductor. Okay, first listen here, and the conductivity of any conductor does not depends on the length of the conductor or the area of cross section of that conductor. It is only depends on the nature of the conductor, and this is the first. And second, the conductivity is also depends on the tau. What is tau? Tau is the relaxation time of free electron. Okay, so you understood about the relaxation time. This is the time taken by the free electrons between two successive collision. Okay, so you know that when temperature is increased of the conductor, then the relaxation time will decrease. Okay, let look at this. Let this is uh, an atom and this is another atom. Okay, now electron moving towards the atom and collide with this atom, and after the collision it will change their path and uh, will go along this direction and collide with this atom again. So here the time taken by the electron to reach from this atom to this atom, this is the relaxation time. Okay, now here this is the average relaxation time of the conductor. Now if temperature is increased, then the electron will get the extra energy and the velocity of electron will increase. That's why the electron will reach here early. So listen here, the time or the relaxation time will decrease. Okay, when relaxation time decrease from this relation, here relaxation time will decrease, then sigma will decrease because sigma is directly proportional to tau. Here conclusion is that when temperature is increased of any conductor, the resistivity of the, the conductivity of that conductor decreases. When, again I repeat again, when temperature is increased, so the relaxation time will decrease, and then the conductivity of that conductor decreases. So we can say here that sigma inversely proportional to the time or to the temperature of that conductor. Okay, now this is finished. Now we will have to understand about the relation between current density and this is sigma. Sigma means conductivity and E electric field or intensity of electric field or electric field strength. Okay, so we have to understand about the relation between these. Okay, now you know, let this is the conductor of length L and the cross sectional area A. When electric potential difference is applied across the terminals of the conductor, then here because this is connected to the positive terminal of the battery, that's why here positive potential will be developed and here negative potential will be developed. Okay, due to the potential difference, free electrons will drifted towards the positive phase of the conductor. Okay, now the charge of the electron, let charge is denoted by Q, but the charge of one electron is minus E. Okay, now after applying the potential difference here, electric field will be developed and the direction of electric field will be along this direction. Due to this electric field, here current, electric current will be flowing through the conductor. Okay, so the relation between drift velocity of electrons and the current flowing through the conductor is what is I equal n e a v d. But this is the electron, charge of electron, but the charge of electron is minus e, so here minus e will be there. Okay, now or I upon a equal n minus e vd. Okay, I upon a, what is I upon a? I upon a is the current density per unit cross sectional area. Current per unit cross sectional area is called current density. Okay, in the previous video we had already studied about that. So this is equal to J. Current density is denoted by J. Okay. Now it will be N minus E and Vd, where Vd is the drift velocity of free electrons. Okay. Now here in the vector form, it will be in the vector form, the equation will be vector J equal n minus e vector vd. Means the current density is a vector form. Okay, now this is the equation, and we know that the value of the drift velocity, the expression for the drift velocity is vector vd equal minus small e vector capital E upon m into tau, where small e is the charge of one electron, capital E vector E is the intensity of electric field or only electric field we can say, and tau is the relaxation time, and m is the mass of one electron. Okay, on putting the value of Vd in this equation, let this is first equation. Then on putting the value of vector Vd in equation first from this equation, so this equation will become vector J equal n minus e, and the value of vector Vd is equal minus e capital vector E upon m into tau. Okay, or here n minus into minus plus, so here e and e multiplied by e square, and we can write here tau upon here m and vector e, so this is equal to vector J. Okay, now this value, n number of electrons constant, e charge of electron constant, tau the average tau is the average relaxation time, m is the mass of one electron, and you know the conductivity, the relation of or the expression for the conductivity is equal n e square tau upon m. Okay, in the previous step we had already studied about this. Okay, now therefore vector j will be equal, the value of this is equal to sigma conductivity or vector E. Okay, this is the relation between current density and conductivity and intensity of electric field or electric field strength or only electric field. Okay, this is the relation. Now this relation is called the vector form of Ohm's law or the microscopic form of Ohm's law. Okay, so this is complete. I hope that you would have understood all the things. Okay. Thanks.